Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at some of the ideas that we were working with yesterday, and we're going to continue with those ideas and then move toward a formula for finding the area of a circle. So remember the inside-outside average method for finding the area of a circle is, you kind of create a square, a large square on the outside of it, find the area of that large square, then create a smaller square that fits on the inside of that circle, find the area of that smaller square on the inside, and then the area of the circle's got to be somewhere in between there, like close to the average. And so if we look at this six unit radius circle that we have here, the larger square would be 12 by 12, so that's 144 square units. The smaller square turns out ends up being 72 square units by the time we figure out the area of all these little mini triangles in there. And then the average between those two ends up being pretty close to, what did we say that was? I don't think we ever finished the process. What is stop it. What is 144 plus 72? That is 216, and then we divide that by 2 because we want the average. So it was about 108 square units for that circle. Okay, probably not the best way of doing it, but it is actually an effective way when you don't have the formula. Let's try it again. Let's take a time to pause. It says Julia's looking at a new circle with a radius of 10 grid units. So there we go. Here's the circle and the radius. There's the center point, and so that's about 10 units. So far on her paper, she has written the work at the right. That she's written this. So what expression should she write to estimate the area of the circle? Well, I don't know if you want to create an expression for that, but let's just see if we can figure out what the area of this circle is. And once again, the circle that I'm referring to, let me get it nice and bold. No, not. I guess we could do that. This would be the circle right there that we're talking about. Okay, so that's a circle with a radius of 10. So I'm going to pause the video. You figure out what the area of the larger square is, what the area of the smaller square is, and so what would the average of those two be for our estimated area of this circle with a radius of 10 centimeters. All right, so this is the work that I've done so far. If the radius is 10, then the diameter has to be 20, and the diameter matches the side length of our larger square. So 20 times 20, it's going to give you, the larger square is going to be 400 square units. We learned yesterday that the smaller square, and whether you remember this or not, I don't know, the smaller square is going to be equal to 2 times the radius squared, which is 100 square units in this case, or I'm sorry, 200 square units in this case. However, if you were to just create these triangles here, the height of this is 10 and the base is 200. So if you take our area of a triangle, which is 1/2 times base times height, that's going to be 1/2 of 10 times 200, which is going to be equal to 100. So this one has to be 100 here, and this one's going to be 100. So them combined is 200, which matches that formula. So what's the average of 400 and 200? Well, they add up to 600, and 600 divided by 2 means that this circle, let me go ahead and put that circle in there again. That circle right there should have an area. No, I can't write it in red. Let's do this. Must have an area of about 300 square units. 300 square units. Okay, I'm kind of interested to come back to this in a second to see, once we get the formula, if we can get the, I'm going to put the little about symbol there, see if how close it comes once we use the formula. Okay, so moving on to the formula. It says, by using the inside-outside average method for estimating, you discovered that the area of a circle is approximately 3 times the radius squared. Did we realize that? I'm not sure if we realized that if we went to that point. But anyway, there is another way to decompose and rearrange a circle in order to find a formula for its area. As you go through this process, think about these questions. If a circle is cut up and rearranged into a new shape, is the area of the new shape the same as the area of the circle? So, okay, let's just think about this. Here's a circle that I've cut in half. If I take the area of this and I decide I'm going to rearrange it like, say, this, did I really change the area of the circle by cutting it up into pieces and putting it together in a different way? No, I didn't. I've just dissected it, rearranged the parts. This, the whole idea of decomposing things and rearranging them. So this is going to play an important part in what I'm going to show you next. And it says, how are the dimensions, the base and the height of the new shape related to the circle? Well, I'm not quite sure how to answer that because I gave this a new height because of the way I stacked it, but whatever. Would this process work for any circle? Well, this will certainly work for any circle. I'm going to go ahead and cross this out because I don't know what I was supposed to do there. This is getting to the main point, though. So here we go. Take a circle and cut it into 8 equal parts. You don't have to actually do that, but just picture this. Remember what we just did. If you were to take this, I just cut it in half and moved it around a little bit. But if you created 8 equal parts, separated them, and stacked them like little pie wedges or pizza slices like this, the area inside here is exactly the same as the area in here. If you were to cut it up into more wedges, 1, 2, 3, 4, 5, 6, 7, 8, if we cut it into 16 equal parts and did the exact same thing, the area on the inside of this shape is going to be the same as the area of the original circle. Okay, so this is where we're going to use a tool that CPM has provided. And to get to that tool, you're going to go to problem number 26, and you can click on that. And let me get this out of the way. And that's a circle, right? Notice how they've colored it in red and blue. That's going to help you keep track of everything. Now, the radius of the circle is from the center point all the way down to the bottom, correct? They've got that measurement right here. And if I rearrange this circle, I can divide it into a number of different parts. The minimum number of parts they want us to break it into is 8. So what I'm going to do is I'm going to drag this circle like this and lay it on end. Now notice how this distance all the way across the bottom was the circumference of that circle, correct? And if I continue with this process and just bring the red wedges up and over the top, we've now got something that's starting to resemble a parallelogram, where this side is going to be parallel to this side, and you can't really say that these are parallel to each other because there's some curvature happening there. But this is when we broke our circle into 8 equal parts. It did that. What if we broke it up into 16 equal parts? What does it look like then? So separate it out. Remember, this entire length along the bottom was the circumference of the circle. And then when I fold it back over, the blue part on the bottom here is going to be half the circumference, and the red part across the top is going to be half the circumference. And notice what's starting to happen to this kind of the curvature that's happening here. It's starting to flatten out. With the more pieces that we divide this circle into, the less of an arc you get on the top and the bottom of that sort of parallelogram looking kind of a shape. What happens if we take it out to 32? You think it'll look more and more like a true parallelogram? Let's go to 32, go through that process, and then we bring it back. Yes, see how it's starting to flatten out on the top and the bottom? And remember, this top right here was half the circumference, and that bottom here was half the circumference, and the distance from here to here was the radius of the circle. Now, what I'm going to do is I'm going to leave it like this. I'm not going to turn it back into its circle. I'm going to leave it kind of looking like a parallelogram, and the more times we split this up, notice what is happening to the sides of this shape and the top and the bottom, the bases. Notice how as we get out to 200 divisions of that circle, we've essentially flattened out the circumference and made the radius almost vertical. Not completely, but almost. So that the height of this is the radius, and the base is half of the circumference. Okay, so let's get back to this right here. When we use this tool and we take this out to like an infinite number of wedges, not just 200, but an infinite of them, you would essentially see this turn into a rectangle where the height of the rectangle is the radius and the base is half the circumference. And if you recall, circumference is pi times the diameter, right? And a diameter is 2 times the radius. So if we take and we divide that by 2, half the circumference, we're going to cancel that out. That leaves this as your base of this particular rectangle, pi times the radius. And now how do you find the area of any rectangle? Well, you multiply the base times the height. Well, the base in this case is pi times the radius, and the height is the radius. So the area of the circle has to be pi times the radius again, and this we can write as the radius squared. That's supposed to be a 2 there. So this is a way of showing, one of the ways of showing how the area formula for a circle is derived. So we're going to use this formula now, and we're not going to use the inside-outside averaging method because that's a lot of work. Here we should be able to just find the radius, square it, and then multiply times pi, whether we're going to choose pi to be 3.14, whether we choose pi to be 22/7, or whether we just hit the pi button on the calculator and round it off. That's more talking about what I just told you there. All right, so this problem number 27 is, I believe, not in your online book, because let's go to your online book here. Let's see what problem number 27 looks like. Yeah, I wasn't real crazy about these problems here. I just want you to practice a bit. So what I'd like for you to do is copy down some circles. Don't worry about drawing them perfectly. And I would like for you to write down for each one of these circles the given piece of information, whether it's the radius, whether it's the diameter, or whether it's the area. And I want you to find the missing piece of information. In this case, we want you to find the missing area. In this case, figure out what the radius must have been if the area was 200.96. And I'm pretty sure I used 3.14 for pi on this. So go ahead and just use that. Okay, so please copy these down. I'm going to pause the video. You pause the video. Use your calculator. See if you get the same answers as me, because we're going to have a check for understanding on this. And then eventually we're going to have an assessment at the end of this week. I want to make sure that you know how to do this. Okay, so go ahead and pause and work through these, and then come back when you're ready and see if you've got the same answers as me. Alrighty, let's see how you did. All right, so for this first circle right here, we've got a radius of 4 inches. So if we're going to find the area, it's pi times the radius squared. So it's going to be 16 times pi. If you multiplied 16 times 3.14, you get 50.24. If you take 16 and you multiply it times the pi button, you get 50.26527, somewhere in there. So that's the answer I went with. I went with the more accurate one by using the pi button. In this case, we're going to have to take the area and divide it by pi, right? Because if you need to find the radius, you got to divide both sides by pi, which will cancel this guy out, forming a giant 1. So 200.96 divided by pi turns out to be 64, or close to it. If let's take a look at this. 200.96 divided by pi That's pretty close to 64, but if I had chosen 200.96 divided by 3.14, the rounded off version of pi, then it's exactly 64. So what number do you multiply times itself to give you 64 for an answer? In this case, the radius has to be 8 feet. Now, let me just tell you, if you're not sure whether or not you got this correct, then just plug 8 feet into the area formula. What's 8 squared? It's 64. What's 64 times pi? It should get you back to 200.96 or close to 201. Here, if we know the diameter is 12, oh no, I think I made a mistake here. Hold on for a second. I'm going to pause and I'm going to fix this. Just so you know, I said the radius is 12, but the radius is not 12. The radius has to be 6. So let me fix that. All right, that's better. So pi times the radius squared in this case is going to be pi times 36. And so when you multiply pi times 36, you get something right around 113.1, depending on which version of pi you use. Here, once again, we've got the area like we did for this problem here. We're trying to find the radius. So you're going to take 154 and divide it by pi, and you get something that's very close to 49, depending on which version of pi you use. So what number do you square or multiply times itself to give you 49? That is 7. So this must have a radius of 7 miles. Here, the diameter is 10, which makes the radius 5. So we're going to say pi times 5 squared means it's pi times 25. So what is 25 times pi? It's around 78.5, somewhere in that vicinity. And then for the last circle, the radius is 1.5. So you square that, it becomes 2.25. Multiply that times pi, and you get an answer of a little bit more than 7. You could say 7.1 or 7.07, 7.05, depending on which version of pi that you used. So from here on out, this right here is your formula for pi. Change that to a different color. I guess we'll just leave it like that. Yeah, just use this as your go-to formula. And I'm going to tell you right now, as you move forward in geometry, into 8th grade geometry with solid figures and then high school, there are some formulas you've got to have memorized. The circle formulas for circumference and for area are formulas you want to have committed to memory, just like your times tables. The formula for finding the area of a rectangle and square, most of you've got that down, and then the formula for finding a triangle. Pretty much all other shapes are made up of either circles, rectangles, or triangles. So if you've got those basic formulas of those basic shapes, you can figure out a lot of problems. Now, of course, it's also wonderful to have all those other formulas memorized, but no reason to memorize too many things because there's a lot to think about, a lot to memorize. So make sure circumference formula and area formula for circles. You've got to have that committed to memory, and you should know how to navigate through a calculator to get these answers. All right, so good luck on your homework tonight, and I believe we're going to do a check for understanding probably tomorrow, or I'll check. It's either going to show, it's either on there today, I can't remember, or I'll have one ready for you tomorrow. All right, take care.
Hey, feeling good.